Hello students. Today we'll continue with the trigonometric identities. Right? I have taken up an identity that is sine theta minus 2 sine cube theta divided by 2 cos cube theta minus cos theta is equal to tan theta. So if you remember, I've told you yesterday also that whenever we are solving such kind of identities, we'll have to simplify the left hand side and get it equal to the right hand side. Okay. So our left hand side is sine theta minus 2 sine cube theta divided by this is 2 cos cube theta minus cos theta. Right? We need to simplify this and get it equal to the right hand side. Okay. So if we just look at the denominator, what is common is sine theta. So if I take out sine theta common, then this will be equal to 1 minus 2 sine square theta. Right here I have taken out sine theta common from here and here. This is sine cube. So out of like this sine cube is sine into sine, right? I have taken out one sine common. So what is left? Sine square. Likewise, in the denominator, cos is common. I'm so sorry, there is no minus sign. This is cos theta, and then what is left? This is 2 cos square theta minus 1. Okay. In the numerator, we have taken out sine theta common. In the denominator, we have taken out cos theta common. Now, sine theta upon cos theta is what? Tan theta. Okay. So, our requirement in the right hand side is what? Tan theta. This part we got it. Now, we need to eliminate this part. Okay. So, how can we eliminate this part? It's very simple. You need to convert sine the numerator, right? In numerator we have sine. Sine if you convert in terms of cos, or if you convert cos in terms of sine. See, either we are changing the numerator or we are changing the denominator. We are not changing both, right? If we convert sine in terms of cos, then the numerator and denominator will divide and you get 1. You just check it out here. This is 1 minus 2. Instead of sine square theta, I can write 1 minus cos square theta. Divided by this is 2 cos square theta minus 1. Okay, so we'll write down the reason as well out here. Reason, for first reason, sine by cos, I have written as tan. So since we'll write here sine theta divided by cos theta is equal to tan theta. This is one reason. And instead of sine square theta, I have written 1 minus cos square theta. This is again the trigonometric identity. This is tan theta 1 minus, we'll open the bracket, 2 into 1, 2, minus 2 into minus cos square, minus into minus will become plus 2 cos square theta divided by 2 cos square theta minus 1. Right? The next step. See what is there in the denominator. This is 2 cos square theta minus 1. So we'll write here 2 cos square theta, and 1 minus 2 is minus 1. And denominator also we have 2 cos square theta minus 1. So this will divide and you get 1. So that means this is equal to tan theta. And our right hand side is also tan theta. We are just left with tan theta in the left hand side as well. So we'll write LHS is equal to RHS. This is verified, or you can even write proved. Right? So in a very simple way, we can derive or we can prove these kind of identities where we need to show that the left hand side and the right hand side, they are equal to each other, right? Now we'll take up another question. Okay, our next identity we have taken is cosec theta minus sin theta into sec theta minus cot theta into tan theta plus cot theta is equal to 1. Right? We need to prove the left hand side is equal to 1. Okay? So, we'll write the left hand side here. LHS, this is cosec theta minus sin theta into sec theta minus cos theta, and this is tan theta plus cot theta. Okay? So cosec theta can be written as 1 divided by sin theta minus, again this is sin theta. Sec theta can be written as 1 upon cos theta minus this is cos theta. And tan theta can be written as sin theta by cos theta, and cot theta can be written as cos theta divided by sin theta, right? These are the conversions. We'll write down the reason here. Reason is what? Cosec theta is 1 divided by sin theta. The first conversion which we have made, cosec is equal to 1 upon sin. Second conversion we had written, sec theta is 1 divided by cos theta. Third what we have written, tan theta is equal to sin theta divided by cos theta, and cot theta. Can you recall what is cot theta? Cot theta will be cos theta divided by sin theta. Right? Okay. I have already written anyways. So now when I find the LCM here, this is sin theta, right? So this is 1 minus sin into sin. This is sin square theta. Likewise here the LCM is cos theta. 1 minus cos into cos square theta. Here the LCM, this is cos theta sin theta. See, this is how to find the LCM of these trigonometric ratios. I have already explained to you in the last class, right? In the last video you can see it. If you do not understand out here, you can watch the last video. Okay? So next will be sin into sin. This will give you sin square theta. Cos into cos will give you cos square theta. Correct? Now 1 minus sin square theta is equal to cos square theta upon this is sin theta into 1 minus cos square theta is again sin square theta divided by cos theta into sin square theta plus cos square theta is equal to 1 divided by cos theta sin theta. Right? Again, we'll write down the reason here as well, that 1 minus sin square theta is cos square theta. 1 minus sin square theta is cos square theta. Likewise, 1 minus cos square theta is sin square theta. Sin square theta. And the last one is sin square theta plus cos square theta is equal to 1. So now the division part. See, I'll write this. I'll just expand it, right? We can just simply divide it. We'll get equal to 1. But for better understanding, I'll just expand this. I'll write in the form factors. This is cos theta into cos theta. Because cos square is what? Cos into cos divided by sin theta. Sin square theta is what? Sin theta into sin sine theta divided by cos theta into 1 divided by, this is cos theta sine theta, right? So now see, it's very simple now. Sine and sine will divide, this cos and this cos will divide, this cos and this cos will divide, and this sine and this sine will divide. So if everything is divided, so what is left? Answer is 1, right? So what we are getting here, LHS is equal to RHS. The left hand side is equal to the right hand side. See, in the previous video and this video, you can make out the difference. See, there is no any particular pattern that you have to follow that, and then you will get the, I mean, you can prove the identities. See, the way you solve all depends on what is given in the right hand side. Is it clear? So, as I told you in the last class also, you will be fluent in solving and proving these identities only when you practice regularly. At least 2 to 3 identities you practice regularly. Try to understand that why you are using that conversion, or why you are using some particular identity to solve that. I mean, to prove the left hand side is equal to right hand side for that particular identity, right? So when you do few questions, 2, 3, 4 questions regularly, you definitely understand the basic of it, right? And then you can solve any other types of questions as well. Okay, so I think we'll do this much for today, right? I don't want to make the videos unnecessarily long. If you still have any doubt, you can always ask me, right? You can write even in the comment box as well, right? Thank you so much.